Welcome to Statistics, where we bring complexity to clarity. I'm excited to have you join me for our 13th unit, Test of Significance. Let's begin by understanding what is statistical inference. Statistical inference is that branch of statistics which is concerned with probability concept to deal with uncertainty in decision making. It refers to the process of selecting and using a sample statistic or estimate to draw inferences about population parameters based on the sample drawn from the population. The subject of statistics deals with statistical estimation and testing of statistical hypothesis. These are the two important functions for drawing inference about the population parameters. Let's understand statistical estimation. Here, this is the population, where every member of the population has the same chance of being selected in the sample, hence it forms a random sample. Here, parameter describes the characteristics of population and statistic describes the characteristics of sample, and estimation is the technique of estimating the population parameter values on the basis of information obtained from the sample. Now, let's see the concept of testing of statistical hypothesis. The estimate thus obtained is not the final form for drawing valid conclusion regarding population from which the samples are drawn. It needs to be tested by applying an appropriate test or method. Such test is known as test of significance. Thus, test of significance can be defined as the statistical procedure for deciding whether the observed difference between sample estimate and population parametric value is significant or not at specified level of significance. Now let's see various terminologies to understand the test of significance. Let's start with point estimate. A point estimate is a single value estimate of a parameter. For example, a sample mean x bar is a point estimate of population mean mu. Interval estimate. An interval estimate gives you a range of values where the parameter is expected to lie. So here we get a range of values. A confidence interval is the most common type of interval estimate. Now let's see confidence interval. Confidence interval measures the degree of uncertainty or certainty in a sampling method. It is denoted by 1 minus alpha, where alpha is the level of significance. So let's discuss level of significance. It is the maximum probability at which one would like to reject the null hypothesis when it is true, or the level of significance is the average proportion of incorrect statements made when the null hypothesis is true. It is denoted by alpha. Let's understand confidence interval and level of significance by plotting a graph. Here, the region between these two lines is say 1 minus alpha, that is confidence interval, hence it is called the acceptance region. And the region beyond it is called rejection region, which tells us about the level of significance, that is alpha. Generally, alpha is 1 or 5%. Hence, the confidence interval will be 99% or 95%. Now let's discuss degrees of freedom. Number of observation minus number of independent constraints or restrictions is called degree of freedom. So these were some of the terminologies which we need to get acquainted to understand test of significance. Further, hypothesis can be of two types. Null hypothesis denoted by H0 or alternate hypothesis which is denoted by HA or H1. Again, alternate hypothesis can be two-tailed or one-tailed. Hypothesis. It is the statement specifying the parametric value of a distribution from which sample is drawn. Null hypothesis at 0. It is a hypothesis of no difference between different populations' parametric values from which samples are drawn. Alternative hypothesis, denoted by HA or H1. The alternative hypothesis describes a changed state or existence of a difference. It is also known as researcher's hypothesis. Now, whether it is one-tailed or two-tailed can be decided based on alternate hypothesis. Here, alternate hypothesis is mu not equal to mu 0, hence it is a two-tailed hypothesis. Let's understand from this plot. Here we have the region between these two lines. It is called acceptance region. It is defined by the confidence interval 1 minus alpha, where alpha is the level of significance. And the level of significance alpha is set to 5% in this example. Hence the confidence interval is 95%. So, based on the confidence interval, this is our acceptance region, and the region other than that is the rejection region. Thus, the rejection region will be 2.5% on both the sides. As the rejection region is present on both the sides, that is, on both the tails, hence it is called two-tailed. Now, here alternate hypothesis is mu less than mu 0 or mu greater than mu 0, so it is called one-tailed. If alternate hypothesis is mu less than mu 0, then the rejection region lies on left side, that is left tail, and if alternate hypothesis is mu greater than mu 0, then the rejection region lies on right tail, that is right side. Now let's see type 1 and type 2 errors. While testing the hypothesis, one is liable to commit two kinds of errors. An error of first kind is made by rejecting the null hypothesis when it is true. The probability of committing type 1 error is denoted by alpha. That is, probability of type 1 error is equal to alpha. Type 2 error is committed by accepting the null hypothesis when it is false. The probability of type 2 error is denoted by beta. That is, probability of type 2 error is equal to beta. With the help of this table, we can easily understand the type 1 and type 2 errors. So, if the null hypothesis is true and we accept it, then it is a correct decision. But if the null hypothesis is true and we reject it, then it is a false decision and it leads to type 1 error. The other cases when null hypothesis is false and we accept it, then it is again a false decision and leads to type 2 error. And in case of false null hypothesis, if we reject it, then it is a correct decision. Now, let's see the procedure for testing a hypothesis. It involves following 5 steps. The first is set appropriate hypothesis, then fix the level of significance, then set suitable test criteria. Fourth is computation, and fifth is conclusion. The first step is set appropriate hypothesis. Here we set null hypothesis as mu is equal to mu 0 and alternate hypothesis as mu not equal to mu 0, that is two-tailed, or mu greater than mu 0 or mu less than mu 0, which will be one-tailed. The next is fix the level of significance. Generally, we fix it at 5 or 1%. The third step is set suitable test criteria. So we need to select a test from Z, T, F or chi-square test. The criteria for selection of the test is if mean of one or two samples are to be compared and the sample is large, that is the sample size is greater than 30, then we should perform Z test. And if we want to compare mean of one or two samples and sample size is less than 30, that is small sample, then we should perform T test. In order to compare variance of two samples or for ANOVA, we have to perform F test. And for goodness of fit or independence of attributes, we have to perform chi-square test. So the next step is computation. Hence, after selecting suitable test, next step will be computation, where we need to compute means of samples, standard error of mean, that is Sx bar, pooled standard deviation if two sample test. And final step is conclusion. After doing the necessary calculations, one has to decide whether to accept or reject the null hypothesis at a certain level of significance. Therefore, the computed value of the test criteria is compared with the table value. If the computed value is greater than table value, the observed difference is significant and H0 is not accepted. Whereas, if calculated value is less than table value, observed difference is non-significant and the H0 is accepted at a given level of significance. Non-acceptance of H0 means the difference between sample estimate and the hypothetical parametric value is a real difference, while acceptance of H0 means the difference between sample estimate and population or hypothetical parametric value can be explained due to chance variation or sampling variation. Thank you for joining me on this journey through our 13th unit, Test of Significance. If you found this unit helpful, don't forget to like, share and subscribe to Statistics for more insights and clarity on statistics. Your support helps us continue creating content that makes complex topics simple and accessible. Follow us on Instagram and LinkedIn.